It's 4 years later. What do I think about Terragrunt now? Let's find out. What's up, everybody? It's Ned Bellavance, nedinthecloud.com, and welcome to another Terraform Tuesday. Before we get into the topic, I want to thank Terrateam for supporting this video. More about them at the break, but if you're a vendor looking to sponsor Terraform Tuesdays, reach out and let me know. The link is down in the description. Now, on with the episode. 4 years ago, almost to the date, I did a review of Terragrunt. It's one of my more popular videos of all time, in fact. You can watch that video here, wherever it appears. But good news, I watched that video again, so you don't have to. And I thought it might be time to reassess my initial impressions of Terragrunt. It's 4 years later. Terraform has gone from 0.14 to 1.9. OpenTofu happened, and I switched my desk around and got a better camera. You're welcome, or I'm sorry. So like I said, a lot has changed. Has my opinion of Terragrunt? Mostly no. Video over. We did it. I'm kidding. You have eyes. You can see the runtime of this video. You know I've got more to say. And I want to start with what I think my previous video got wrong, or at least approaches incorrectly. Throughout the older video, I kept saying how Terragrunt was meant to solve issues that existed with Terraform before recent developments and enhancements. But I don't feel like I was ever that clear on what the exact shortcomings were and how updates to Terraform solved it. That video was also shot long before I started writing scripts for the videos, so I pretty much just had an outline, maybe not even that, and just riffed. I ended up repeating myself a lot without adding any additional clarity. So in this video, I plan to do a much better job. We are going to start with the problems Terragrunt is trying to solve. Then we're going to walk through an example. We'll take an existing configuration that is not using Terragrunt and transmogrify it to using Terragrunt so you can see how it solves real problems. After that, we'll talk about some other solutions that exist and just the general design philosophy when it comes to Terraform and dealing with some of the issues that Terragrunt is trying to deal with. Before that, one thing I'd like to say is that Terragrunt is a well-written application, and it does what it says on the tin. Gruntworks espouses a philosophy of dry code and disaggregated configurations, and they deliver on it with Terragrunt. With this video, I feel like I might be addressing two different kinds of viewers. There's those of you in the camp that you're already using Terragrunt in your organization, and then there's those of you that are considering implementing it. If you're in the first camp, you're using Terragrunt today, there's no reason for you to stop. The project is actively maintained and gets updates. So assuming it meets your needs and it isn't getting in your way, the switching cost to go to something else is probably going to be too high. Now, if you're not using Terragrunt today, but you're trying to solve some specific problems, I still don't know if Terragrunt is the ideal solution, but that determination requires nuance, and hence we have the remainder of the video. So buckle up, y'all. We're going to get nuancy. In my eyes, there are three problems that Terragrunt is trying to address. The first is managing large configurations with thousands of objects. The second one is managing multiple environments that are all using the same basic configuration. And the third is reducing your code repetition by embracing don't repeat yourself principles or dry principles. Now allow me to expand on each of these a little bit more. First, massive configurations. If you've watched my Terraform Stacks video, you know that having a massive root module has become something of an anti-pattern. Now, part of that is because when you have a massive root module, the planning cycles start getting really long. Every time you run a plan, Terraform has to refresh the state based off all the resources in your config. And if you are up to thousands of resources in your root module, it's going to refresh every single one of those. That massively slows down development, and it locks your state for an excessive amount of time. So if you're dealing with that kind of scope and sprawl, Terragrunt can help you break your root modules into smaller deployments, each with their own instance of state. Another reason is that components in the same root module sometimes can't deploy because of planning dependencies. It literally cannot plan out the deployment of one set of resources because it needs values from another set of resources that don't exist yet. Sometimes Terraform can get around that, but there are occasions where it cannot, especially if you have to instantiate a provider and a provider is going to be referencing a thing that doesn't exist yet. To do that in a single root module, you have to target specific resources with the target flag or break those into two separate configurations and use some automation to make sure you're doing them in the correct order. Another big reason to break up massive root modules is because of blast radius, change rate, and who's responsible for the resources inside of a configuration. If you have the resources for Team App A and for Team App B, you don't want changes to the Team App A resources to accidentally break something with Team App B. And for that reason, you might want to put them in separate root modules. So with that context in mind, Terragrunt is trying to address some of those issues. The next big problem that it's trying to address is dealing with multiple environments. And there's roughly 3 common approaches to dealing with multiple environments. There's the folder-based approach, where each folder represents an environment and has the configuration in it. Then there's branch-based, where each environment is represented by a branch in your Git repository. And then lastly, there's a logic-based approach. And that is where you have a single default branch or a trunk branch in your repository. All of the environments use that trunk, and the logic inside of the configuration helps dictate what is deployed. For instance, if it's production, maybe you have some logic where you use larger virtual machine sizes or a better tier of storage for production where you wouldn't use it for development. If you've gone down the folder-based approach, then you know it can be very difficult to keep all your environments in sync. After all, you're copying and pasting updates from one environment folder to another as you try to promote changes. Wouldn't it be nice to define settings in a hierarchy and let each environment inherit those settings? Terragrunt sure seems to think so. So if you're doing folder-based management, Terragrunt is going to work for you. If you're currently using branch or logic-based, Terragrunt doesn't have as much for you. The last big goal here is to reduce the repetition in your code by allowing you to define settings in a hierarchy and declaratively generate files for your root module. Breaking up your massive configuration is less painful if you don't have to maintain a bunch of new backend and provider files for each new root module. And maintaining 10 or 20 environments with this kind of inheritance reduces the need to update a bunch of terraform.tffrs files or something similar every time you want to update a setting for all of your environments. All of this might seem a little esoteric, so let's apply it to an actual example. But first, let's learn a little bit about Terrateam. In the world of infrastructure, there's always a new tool to learn, and it can be hard to keep up. That's where Terrateam comes in. Terrateam is the GitHub native GitOps CI/CD platform for teams who simply want to scale their Terraform and OpenTofu workflows, all without leaving GitHub. Your entire configuration lives in Git right next to your code. With Terrateam, you can orchestrate Terraform, OpenTofu, CDKTF, and Terragrunt, hey, Terragrunt, through pull requests, handle layered runs, and manage complex multi-repo setups with ease. I'm excited to announce that Terrateam is also now open source. Getting started is as easy as running Docker Compose up. Check out the Terrateam GitHub repository for the quick start guide that's linked down below, and join a growing community of SREs and DevOps professionals. Thank you to Terrateam for your support of this episode. Now back to Terragrunt. All right, over in VS Code, I have an example configuration that we're going to transform with Terragrunt. If you're looking for the files, you can always find them in my Terraform Tuesdays repository. The link is down below. The application that we're working with is in the original directory. I'll expand that, and in the environments directory, there are 3 environments defined. We've got dev, prod, and QA. Let's take a look at the development environment. In the development environment, I'll open up the main.tf file so we can see what's in there. And this is really just stitching together 4 modules that make up the application for this environment. At the very top, I have a provider block for the Azure RM provider, since that's the provider that this application is going to be using to deploy infrastructure. And inside of the block, I have the subscription ID set, and that's pretty much it. Below that, we just have a module block for our networking, a module block for our front end, a module block for our back end, and a module block for our database. Going back up to the networking module, the source is going to be the modules directory that's a few directories up. So all of these modules are located along with the configuration itself. If I expand the modules directory, there they are: backend, DB, front end, and network. For our network module, we're feeding it some information that is defined by input variables, and I'm passing the settings through a terraform.tf vars file that we'll look at in a moment. One thing that I want to point out about the backend and database modules is that they are reliant on a subnet that is created by the network module. Specifically for the backend, it's looking for a subnet named backend, and it needs the ID of that subnet to deploy. Likewise, the database module is looking for a subnet named DB to get that subnet ID from the networking module. Now let's take a look at what is in the terraform.tf vars. Inside the TF vars, I have a bunch of common settings set here for all the input variables that are defined, but specifically I want to call out that the common tags has an environment tag that's set to dev, and the networking information is using the 10.000/16 address range for the network and the subnets inside of it. Moving over to the terraform.tf, we're using an Azure RM backend with a partial configuration. The only thing I have in here is that for the key, we're starting with dev/ and then terraform.tf state. So you can imagine when we go over to the QA environment, it's going to be the same except QA. Now, where are the rest of the backend settings? They're up in backend.hcl. Opening that file, I have the container name, the resource group name, and the storage account name. To use a partial configuration in this Terraform setup, we would run terraform init and then specify the backend config argument and pass it the path to this backend.hcl file. There's nothing special about the .hcl extension on here, except that using the .hcl helps with formatting and linting of the file. Taking a look in the QA directory, it's basically the same exact setup, except when we look in the terraform.tf vars, the environment is now QA, and the address range is now 10.2 instead of 10.0. The other big change is in the terraform.tf in the backend block, our key now starts with QA instead of dev, and we repeat the same for prod. This means that there is a lot of code duplication across our various environments. And in the world of dry programming, that's a big no-no. We want to minimize the code duplication, especially if we want to update something about that code. Instead of having to change it in 3 places, we'd really like to just change it in 1. So where are there some opportunities for us to improve our code by removing redundancy? In our dev environment, up at the top, we have a provider block defined. And that provider block is exactly the same for every environment we're working with. Come to think of it, So are all the module blocks. Those are exactly the same. So if we could somehow produce all of these modules and the provider block programmatically through a hierarchy, that might be nice. Next up, we can look at the Terraform.tf. The required providers and the backend are all essentially the same, except the backend key changes a little bit depending on the environment involved. So it'd be really nice to just define this once as well. Moving into our backend.hcl, this is exactly the same for all three environments, so I'd really just like to define it once and use it for all the environments. And then lastly, going into the TF vars, most of these settings are the same across the environments, the location and the subscription, so some of this information I might want to define higher up in the hierarchy, and then the rest of it can be environment specific. With the goal of drying out our code and also increasing its efficiency, let's take a look at the Terragrunt version of this exact same configuration. Back in Visual Studio Code, there's a Terragrunt directory that has the Terragrunt version of this configuration. Now I'm going to have to introduce some concepts as we go through the Terragrunt configuration so you'll understand what's happening behind the scenes. The first thing I want to mention is that Terragrunt is a wrapper around Terraform or OpenTofu. So realistically, it's doing some of the initial setup for you based off of Terragrunt specific files, and then it's handing things off to Terraform or OpenTofu to do the rest of the work. So keep that in mind as we move through the configuration. Just like the original example, my Terragrunt directory has two subdirectories, one for environments and one for modules. Let's expand out the environments to see what's going on in there. In here, we only have a single dev environment defined. We'll see how we define additional environments in a little bit. Inside of dev, unlike before where we had a single root module, we now have 4 subdirectories. Each one represents one of those modules that we were invoking from our root module. Terragrunt calls these stacks. So each of these folders represents a stack. Let's start with the network stack and see what's inside of it. Inside the network stack, we have a Terragrunt cache directory, which don't worry about that right now. We will come back to that. We have a lock file, which defines which versions of the provider are being used by this configuration. And then we have a terragrunt.hcl file. Terragrunt uses HCL files to express its configuration. This is really nice because if you're already comfortable using HCL because you work with Terraform, you don't have to learn a whole new language and syntax to make use of Terragrunt. Terragrunt interprets what's in these HCL files to help you build your stack. Let's take a look at what's in this terragrunt.hcl file. Now, in order to understand what's in this file, I do want to point out one thing. When you're running Terragrunt, it's executing from the context of the stack directory. So when I invoke Terragrunt, it's going to be running from the context of the network directory that we're in right now. And that's important to understand as we look through the configuration, is understanding where this is running from and how to get to other paths in the folder hierarchy. One of the interesting things about Terragrunt that allows it to inherit settings from higher up in the hierarchy is the include block. The include block allows you to include configurations that appear higher up in the hierarchy. So in our include block, we're passing the path argument a special function defined by Terragrunt that has it go and look in parent folders for a file named terragrunt.hcl. You can put a different file name in the parentheses if it's not named terragrunt.hcl, but otherwise it will walk the folder tree upwards until it finds a file named terragrunt.hcl, which I do have in the root of this configuration. We'll take a look at that file in a second. The next block is the Terraform block, and this defines the Terraform configuration that it should be using for this stack. And the argument that it uses is source. In here, we use another Terragrunt native function, and this one gets the parent directory of the Terragrunt configuration. So it's basically walking back up to the Terragrunt folder and then getting the path modules/network where we have our actual network module. That double slash at the end is not a typo. That's a requirement for the way that Terragrunt handles modules. So keep that in mind when you start writing your own. So this is going to walk the directory up to the parent and then back down to the module's network directory to find the module that corresponds to this stack. Next up, we have what basically takes the place of our terraform.tf vars file. It has a number of different settings that are used as inputs for the input variables that are defined for our network module. We've got the CIDR block and the subnets. Now, if you remember from our network module, there was a little bit more to it than just the CIDR block and subnets. In fact, if we expand back out our original configuration and take a look in the dev environment TF vars, we had location, subscription ID, prefix, and common tags. So there are some other settings. Where are we getting those settings from? Well, those settings are coming from the terragrunt.hcl that's found in the root of this configuration. Let's take a look at what's in there. There's the terragrunt.hcl file in the root of our directory, so let's take a look at its contents. The first thing, it's defining some locals. These work the same as local values in Terraform. It's a way to define local values that you want to reuse inside of this context. The first line here is creating a local called backend config, and it's using a function called read Terragrunt config. As you can imagine, this reads the contents of a Terragrunt configuration. Inside the argument, we're using the find in parent folders function and telling it to look for a file called backend.hcl. Now, the important thing to remember is that the way that this terragrunt.hcl configuration is getting added to our network stack is through an include block. So everything being defined here is being added to that network stack configuration, which means that it's also executing from that context, which is why the find in parent folders works, because it's starting out from that network stack directory and walking up until it finds the file backend.hcl. Remember that our backend is common across all the environments. So I've added a backend.hcl file that lives in the environments directory. And inside of there, I have a locals block that defines the container name, the resource group name, and the storage account name. Because it's common to all of the environments, I wanted to place it somewhere that was above the environment definitions. Going back to the terragrunt.hcl, I'm going to take the contents of that local value I just loaded, the backend config, and store the individual settings in their own locals. That's not necessary, but it does make things easier to reference later. Below that, I'm loading some environment-specific variables that are stored in a file called env.hcl. And that file is located inside the dev directory, and it defines some settings that are specific for the development environment. This is where we're getting our subscription ID, our location, our tags, our prefix, and I'm also going to set the Azure RM version that's being used. This is super useful if I want to test out upgrading to a newer version of the provider just in development. I can update this env.hcl file just for the dev environment, and Terragrunt will use the newer version that I specify here versus what's specified for the other environments. All of these settings are environment specific because I might want to use a different subscription ID for my prod and my QA. I might want them in a different location, and I certainly want to set the environment tag to something else. Moving back to our root configuration, below the environment variables, I'm going to extract just the subscription ID because I'm going to use that in two different places. The first place I'm going to use that is to generate a provider block. Unlike when we had our root module before, where we were stitching the other modules together and we had a common provider block, that's not going to exist with this Terragrunt setup. So we need a way to express the provider block for each stack. And I'm doing that with a special block type called generate. And in this case, it has a name label of provider. Inside the generate block, we tell it the path where we'd like it to create a file. I'll call it provider.tf because that seems to make sense. And then we have an if exists argument. This determines whether or not Terragrunt should overwrite a provider.tf file if it finds it. And I say, yeah, go ahead and overwrite that if you find it. Lastly, the contents specify the provider block for Azure RM, as well as the subscription that should be used for that provider. And we're getting that information from that env.hcl configuration that we loaded into our locals. The other point of commonality is the backend. And we're going to dynamically generate a backend block by using the remote state block inside of our configuration. The remote state block allows you to define which backend you're using, and then it has a generate argument that tells it where to create this backend config. We'll tell it to create the backend config in a backend.tf file, and if that already exists, go ahead and overwrite it. The config will include the settings that will be added to that backend block inside our configuration, and we're specifying the subscription ID, resource group name, storage account, and container. For the key, remember that was a point of differentiation as well. For our development environment, it was dev/terraform.tf state. For QA, it was QA/terraform.tf state, etc. To have that same type of differentiation, we're going to use a function here called path relative to include. This will resolve to the path of the file that has the include block, which is the terragrunt.hcl file inside of our network stack. When Terragrunt renders the path for this function, it's going to be environments dev network, and so that will be added to the key ending in terraform.tf state. Another point of duplication was the required providers block, and we can remove that from our existing modules and generate it here in a file called requiredproviders.tf. And inside of here is where I'm defining what version of the Azure RM provider to use, and I'm getting that from the environment variables that we loaded from the env.hcl. So this will use 4.11.0 because that's what I defined for the development environment, but I can choose a different version for QA if I want. Lastly, because we want to use some of the values that were found in env.hcl, we're going to pass those as inputs to include when we're deploying our networking stack. So that is the entire configuration for the networking stack. And then we rinse and repeat for each additional module, although there is something that I want to point out about the database and backend because those have dependencies on the networking stack. Inside of the backend directory, in the terragrunt.hcl, it starts out basically the same. We're going to include our root terragrunt.hcl file, and we're going to source our Terraform configuration from the backend module in the modules directory. But now we have a new block in here, that's the dependency block. This introduces a dependency on another stack in the configuration. Don't worry about the mock outputs just yet. The other thing that the dependency block does is allow you to reference outputs from another stack. So down under our inputs, remember that the backend module required a subnet ID to deploy to. And so for our subnet ID input, we're using a reference to dependency.network.outputs.subnets, and then we're getting the backend subnet from that map and returning the ID property. Now imagine that we haven't deployed the network yet, but we're trying to simultaneously plan out all these stacks. There is no value yet for the ID for the backend subnet. So the planning process for our backend stack is going to fail. It doesn't have an input for an input variable. How do we deal with that? Well, the way that we deal with that is by creating some mock data to use during planning. And that's what the mock outputs portion of the dependency block is for. Inside the mock outputs argument, you define the outputs that you want to have mock data for, and then what that mock data should be. We need an output called subnets that has a map of the subnet name to its ID. So I add an entry here for backend and give it an ID of a placeholder subnet ID. Now the Azure RM provider does validate the form of this, so it actually has to be something that is syntactically correct for a subnet ID, otherwise it'll throw an error. If we look inside the database terragrunt.hcl, I'm doing the same thing, except this time the subnet is named DB instead of backend. Okay, that covers the entirety of the terragrunt.hcl configuration. How do you go about deploying this thing? You can run Terragrunt in one of two modes. You can do it stack by stack, or you can run all stacks that are in subdirectories. We'll start by looking at how you run it against a single stack by running it against the network stack. So I'm going to pull up my terminal here and navigate into the network directory. From there, I'm going to run Terragrunt plan. This kicks off the Terragrunt process that is going to go through all of our configuration files and render out that configuration. Once that configuration has been successfully rendered out, it's going to pass it over to Terraform to execute the actual plan process. Included in that handoff will be all of the input values expressed as environment variables during the course of the run. If we take a look at what's in the networking directory, we saw that Terragrunt-cache directory earlier. This is where it actually renders out the configuration it's going to use. If I expand it out, there is a subdirectory path here that actually has every module that makes up the general configuration. The one we care about is network, so I'll expand that. And in here is the rendered configuration for Terraform to use based off of what was in our Terragrunt configuration files. So we see there's the required providers file that sets the version to 4.11. Here's the backend.tf that defines the backend it should use. And here's the provider.tf that generates that provider block along with the correct subscription ID. If we wanted to deploy this, we could do a Terragrunt apply. If we'd like to render all the stacks at once, we can go up one directory and clear this out here. And now we're going to run Terragrunt with the run all option and then plan. And it will go into the subdirectories of the development environment, and it will run a Terraform plan against each of those subdirectories. I'll go ahead and kick that off. And the first thing that it comes up with is it lets us know that it's grouped the processing of these stacks into two separate groups. First, we have front end and network. Because those don't have dependencies on anything, those can be deployed in parallel. Then we have back end and database. And those do have dependencies on the network stack, so they can be deployed in parallel together, but they have to wait until the networking stack has been successfully deployed. Terragrunt used our dependencies to determine the order in which it needed to deploy stacks. If we scroll down through the planning process, when we get to the database and backend processing, it warns us that our network stack doesn't have any outputs yet, so it's going to use the mock outputs that we've set up for both the database and the backend stacks. At the end, it successfully generated a plan for all 4 stacks, and if we wanted to, we could add an additional flag to save those plans to files, and then we could execute those plans by running apply. So far, we've walked through the configuration of a single development environment defined by Terragrunt, but the real power gets expressed when you add an additional environment and see how easy it is to update that environment or update settings as a whole. So in my environments directory, I'm going to add a QA environment to my existing configuration. And what I'll do is simply copy all of the folders and the environment file from my dev environment to my QA. Now, they're not exactly the same. I do need to make some updates here. So in the env.hcl file, I'll update that to QA for the environment and update our prefix to QA. And maybe I'm not ready for 4.11. Maybe I just want to stay on 4.10 for my Azure RM version. We also have to make some changes with the network, going into the terragrunt.hcl there and updating the CIDR block to use 10.2. We could, in theory, use local values at the environment level to set these instead of defining them in the terragrunt.hcl for the network, and I leave that as an exercise to you. What's nice is the rest of the stacks actually don't have any configuration differences between the different environments, so I don't have to customize them. It was really just the network stack where I had to update those IP address ranges. So now with just a few changes, we now have a full QA environment that we can deploy. If I pull up the terminal and clear out, and let's head up to the QA environment now, I can do a Terragrunt run all, and I'm going to need to initialize this configuration because I'm changing provider versions. So I'm going to run an init here and specify the upgrade. Remember, this command is really just being passed along to Terraform after Terragrunt does its work to generate the configuration that's being used for each stack. So I'm essentially telling Terraform you need to reinitialize and upgrade the version of the provider you're using, which is actually a downgrade to 4.10 for the QA environment. Once the initialization is done, we could run a Terragrunt run all plan or apply to deploy our QA environment. By defining configuration files at different levels of the hierarchy, that means that we only have to change things in one place if we want to update everything about each environment. If I want to switch from using Azure for my backend and instead I want to use an S3 bucket, I can update that in the terragrunt.hcl at the top of the hierarchy, and that will take impact to all of the environments that I'm managing. Whereas if I just want to change something about a single environment, I can go into the env.hcl for that specific environment. This is what Gruntworks is pointing at when they talk about dry programming and drying out your code. It's reducing the repetitiveness of what you're coding, and then also making it easier to maintain and update over time. Listen, you got this far in the video. Time for a little bit of philosophy. I've got some opinions, some thoughts on infrastructure as code and automation and where Terragrunt fits into the whole thing. Feel free to disagree with me in the comments. As Terraform was being developed and as it continues to be developed, the team behind it has to make some design choices. What's in scope of Terraform native and what's out? Many of the things that Terragrunt is trying to address are things that the Terraform team decided were out of scope. Things like configuring the backend dynamically, stitching together disparate configurations, or deployment to multiple environments. Now, Terraform does have some features that can help in all of those categories. There's the remote state data source to pull info from one config to another. You've got the Terraform Community Edition version of workspaces to help with multiple environments. Now, if you watched my video about workspaces, you know that's not my preferred way of dealing with multiple environments, but you can use them. They are there. And if you're willing to jump over to the world of OpenTofu, you can define your backend with variables now if you choose to do so. But basically, HashiCorp looked at these features along with managing state, having hierarchy for variable values, and fully automating deployments and said, that belongs in something else. That is not the province of Terraform native. And so the direct result of that decision is that we have a plethora of Terraform automation platforms and solutions that are there to fill in the gaps. And Terragrunt is one of those solutions. HCP Terraform is another. Do you want to deal with multiple environments declaratively, have value inheritance across a hierarchy, and not have to worry about managing your state backend? HCP Terraform and Terraform stacks will do that. So will M0. So will Spacelift. The point of these automation platforms is to fill in those gaps. Terragrunt, in particular, is very opinionated on how you should be managing your components and environments, namely by using a complex folder structure. It's not necessarily bad, but it does lock you into their way of doing things, and extracting yourself could be pretty difficult. I've talked to more than one person who doesn't really want to use Terragrunt anymore, but they also don't want to spend months refactoring everything and doing extensive state surgery. And make no mistake, splitting what would be a root module into 4 or more separate modules, each with their own state data, does introduce its own set of problems. For any reasonably sized configuration, you really don't have to split the root module up. And Terraform works better when you don't do that. Remember that weird mock data thing we had to do with the backend and the database stacks? You don't have to do that when everything is part of the same root module, because Terraform knows how to interpret the fact that I'm going to have an attribute from this module and I need to pass it to that one, but I don't have the exact value yet. Eventually, it might make sense to break up the configuration, but the reasons to do that have less to do with dry coding and more to dealing with blast radius, proper access permissions, and aligning change rates. With the introduction of moved, import, and removed blocks, actually moving stuff from one configuration to another, if it becomes necessary, is way less painful than it was in the past. Keeping your things together in a single root module makes it a lot easier to reference attributes of one resource to another. When it comes to dealing with multiple environments, my mindset on that has been changing. I used to like branch-based management, but lately I think that trunk-based development with logic bundled into your root module, that's probably the way to go. You can add an environment by adding another tfvars file to an environments directory, and then having automation take care of the rest. All of your environments using the exact same configuration on the exact same branch, and the difference being the values you pass through tfvars and internal logic to handle those values inside of the configuration. If that sounds interesting to you, I do plan to do a video at some point demonstrating what that looks like, so keep an eye out. Despite it being 4 years, I think my conclusion hasn't actually changed all that much. Terragrunt is a well-written tool that does what it says on the box. If you're using it today and you're happy, more power to you. If you're curious about it, I think you need to understand that there are some trade-offs and that the tool is opinionated about how you design your configuration. Thanks again to Terrateam for their support of this video. Please go check them out and stay tuned for a live stream on December 17th featuring Malcolm from Terrateam and Soren from TerraMate, where we argue about running apply before or after merge. It's going to be a fun time. Until then, keep calm and terraform on. I just want to point out that my original Terragrunt video was 15 minutes. This one is pushing 45, so you're welcome.